And
I can do a quick introduction of myself if you want. Sure. So you're ready to go ahead and start now?
I think so.
Okay. So I guess good afternoon there, or good evening there. My name is Steve Moran. I'm the Senior Director for Government Affairs and Partner Relations at Spire Federal, which is a part of Spire Global. So I'll be talking to you today about Spire's capabilities, and actually I have a little slide here that talks about the outline of what I'm going to present. I'll have a short overview, high-level overview of Spire, and then I'll go into some of our key markets and capabilities and offerings in a number of these markets. And then I'll talk a little bit about employment opportunities at Spire and kind of new space in general. And then end with a bit on my career path and what you might expect as you guys enter the space community or other, engineering or science communities as you move forward down your career. Mine has been a varied career path, and I think you'll probably find the same thing for yourselves as you go through. You're not going to start in one job and work for 40 years in that same job. So that didn't happen to me anyway. Okay, so just a quick overview of the company and what we do. We operate one of the largest private constellations in the world. We have 120 satellites on orbit right now. We're collecting Earth observations data. We're collecting maritime tracking information globally, aviation tracking information. We offer, we were founded in 2012, and since then we've really pretty much had our heads down, building out our infrastructure, our satellite constellation, our ground system network. And we realized a couple of years ago that there was probably value in the space services that we can offer, and so we've actually turned that into a pretty good part of our business now, offering hosted CubeSat, custom CubeSat capabilities, as well as something new that we offer, which is software in space, because all of our payloads are reprogrammable on orbit. It's very easy for us to upload new software, and we constantly do that ourselves for our own operations, but we can host software in space now too. So we have shown that we can take an idea from concept to on-orbit operations in as little as 6 months. So we're very fast, we're very reliable because we've launched over 140 satellites. We currently have 120 in orbit right now. And I'll get deeper into some of this as we go along here. So let me see, did I go? Yeah, okay. All right. So I mentioned that we have 120 satellites on orbit. We also own and operate our own global network of ground stations that are dedicated to servicing this constellation. We have 32 ground stations right now, and you can see their locations here. There's one that's not shown on here. We have one in Antarctica that we commissioned late last year. Yeah, 32 global ground stations, multiple antennas at each ground station. So you can see we have over 70 total antennas for managing the contacts with our satellites. The way we collect our data, everything is encrypted from the time it's collected by the payload on orbit, downlinked to our global ground station network, and then through our VPN into the cloud. We do actually all of our mission management, our constellation operations, our satellite control in the cloud, and we do all of our data processing and dissemination in the cloud as well. And you can see the different tracks there for ADS-B, AIS, Earth Intelligence, and then for customer systems like hosted payloads and custom CubeSats. And this is all encrypted all the way through until it goes out to the customer. So highly secure TT&C links, data links, cloud-based processing, and data dissemination. Just quickly to start into our products, Spire Maritime is based on AIS receivers that we have on board our satellites. AIS is the automatic identification system that all maritime vessels over a certain length are required to carry. They transmit their position and other information about the vessel. Originally, AIS was designed as a terrestrial network, and you can see that in the white areas there, which is areas that are close to land, you get good reception of AIS from the terrestrial networks, but not over open oceans or anywhere that's not near land. And then we've also addressed another issue with AIS, which is high traffic zones. You can see in those red areas, which are the areas that are have dense shipping. They're dense shipping lanes. It's very difficult sometimes to sort out the signals because there are so many AIS signals being transmitted close to those high traffic zone areas. And what we've done is outfitted a couple thousand vessels globally with the ability to receive AIS signals around them and then retransmit up to space and back down to our ground networks in those high traffic zones. So we're able to sort out and deconflict those signals. So we have a really unique solution for high traffic zones that we call dynamic AIS. And you can see we're getting upwards of 300,000 vessels a day now, which covers about 90% of all global maritime trade. We're able to track those vessels. Similarly, in aviation, we use the ADS-B system, Automatic Dependent Surveillance Broadcast, which is a mandated system by ICAO that all civilian aircraft over a certain size have to carry, just like in the maritime arena. And they continuously transmit their position from the aircraft. That was originally also designed as a terrestrial network, and you can see what you get from terrestrial coverage there on the left. But when you start picking up those signals from space, you fill in all of those gaps in the areas that are not covered by the terrestrial networks. So we combine terrestrial and space-based coverage to fill in the whole globe, the whole picture of air traffic around the globe. And we're getting upwards of a couple hundred messages per hour per satellite right now. So it's just a tremendous amount of data that we're providing. We're on track right now to fulfill the ICAO, what's called the 4D15 mandate, 4D being 3D plus time. And our latency right now is a little over that 15-minute requirement, but we're doing a major constellation upgrade to get that data latency down. So we'll be able to fulfill the ICAO mandate here in the next year or so. we have really good coverage over the poles because we have so many satellites operating in polar orbits, polar sun synchronous orbits. So we collect really, really good information, both maritime and aviation, over the poles as well. Okay, we have an in-house global numerical weather prediction capability that we run operationally, just like the national forecast centers do. We're running a 12-kilometer grid spacing global model. We run it operationally, so we do a short-range forecast. We run our models 4 times a day, and those are on supercomputers, just like National Weather Service or UK Met Office or ECMWF. And we run that short-range model 4 times a day, and that puts out forecast for every hour in the next 24 hours. And then we run a medium-range forecast twice a day that outputs forecasts for every 6 hours out to 7 days, and we're moving to 10 days with that. And then we also have a hindcast capability as well as a reanalysis capability for historical weather forecast data. Our forecast outputs data in flight levels up to about 45,000 feet, or in isobaric levels up to about 80,000 feet. Like I said, we're doing a global model. We're also moving to a regional modeling capability. And then we have another forecast that we call optimized point forecast, where for any location on the globe, any latitude, longitude, we can produce a highly accurate weather forecast that takes into account local data, local terrain, local obstructions like mountains or large buildings. And we assimilate data that's available from local sources to create a highly accurate forecast for any point on the Earth. And right now, I think we're publishing pretty much all of the major airports around the world and the major maritime ports. We produce those optimized point forecasts. And the way we do that, the one advantage we have compared to the national forecast centers is we assimilate all of our own radio occultation data. And I'll talk in a minute about radio occultation data, but we're the largest producer in the world of GNSS-based radio occultation data, which is important for numerical weather prediction forecasting. Here you can see the kinds of variables that we produce in our short range and medium range forecasts. We bundle those in packages like for maritime, aviation, agriculture, renewable energy. We have a package for commercial spaceports. We have a package that we've developed for unmanned systems. So we're going after the commercial weather market pretty strongly. A lot of our maritime customers that have been customers for the AIS data are also now customers for our weather forecast data. We have particularly good forecasts over open ocean areas. So we've had third-party assessments comparing our open ocean forecast with some of the national models, and we come out on top primarily because we're assimilating all that radio occultation data over the open oceans. So let me talk for a minute about radio occultation data. That's a key part of our Earth observations, or what we call Earth intelligence data. You can see where we started back in 2018 or so with a fairly sparse set of observations for radio occultation. and where we are today. Actually, we're beyond this today. We have very, very dense coverage of the Earth from a radio occultation perspective. And what is radio occultation? So what we do is our satellites are looking at the GNSS signals as they transit the atmosphere and as they reflect off the surface of the Earth. And as those signals transit the atmosphere, they refract, and by measuring the bending angle, you can derive vertical profiles of temperature, pressure, and humidity. And as you can imagine, that's kind of like the data that weather balloons collect. And so we're doing that about 10,000, a little over 10,000 profiles per day of vertical profiles through the atmosphere of temperature, pressure, and humidity. And you just can't get that data anywhere else. So we have a really good system for collecting radio occultations. We're selling that radio occultation on an operational basis to NOAA, to UMETSAT, and that RO data is being used in operational weather forecast by the Weather Forecast Center, by the national centers, and we're assimilating all of that data into our numerical weather prediction model. From reflectometry, which is looking at the GNSS signals as they reflect off the surface of the Earth, you can derive information on sea ice height, extent, and characterization in terms of first year versus multi-year ice. We get global soil moisture measurements because the GNSS signals penetrate a few centimeters into the surface. We can get that top level surface soil moisture, and these also act similar to scatterometers. So we get ocean surface height and ocean surface roughness and ocean surface winds from this data. And the ocean surface wind data, although it's not, it doesn't give you wind direction, it gives you wind speed. So that's also very important for our maritime customers and for our numerical weather prediction models. You can see how we've grown from down below 1,000 radio occultation measurements per day up to where we are now, this is a little bit old data. This is from 2020, the end of 2020. We're averaging about 11,000 radio occultation measurements per day right now. We are the only operational radio occultation data provider to NOAA right now. They're buying 3,000 radio occultation profiles per day from us that get assimilated into the National Weather Service weather forecast models. We're similarly with UMETSAT, ECMWF and UK Met Office are getting our operational radio occultation data for their numerical weather prediction models. Along with the radio occultation, we're able to do ionospheric measurements as well. So we're measuring total electron content, electron density profiles, and we're able to detect scintillation events. So we're continuously measuring scintillation, but when we detect an event, we switch modes and downlink at 50 hertz rate, just like the cosmic satellites do. So we're doing, this data is a little old. We're doing a little over 10 million TEC observations per day right now. And that data goes with our radio occultation data to NOAA and then over to the Space Weather Prediction Center for help with modeling with their space weather models. This is just a little bit on our sea ice measurements. You can see we are measuring sea ice height to within about 3 centimeters RMS. And this is very comparable to the Cygnus satellite that NASA operates. So NASA is currently evaluating our sea ice data for operational use. That was sea ice height. This is sea ice extent. We're able to measure the boundary between water and ice. So we're getting sea ice extent. And this is about 98% agreement with the standard sea ice extent maps that exist right now. So very valuable data in the polar regions. And then in terms of sea ice classification, you can see on the model here, these are our sea ice measurements. Green is first year ice, yellow is multi-year ice, very valuable in determining, in predicting when ice is going to melt and new routes are going to open up. And you can see how we compare on the left with the standard models. In terms of soil moisture measurements, we're getting global soil moisture measurements, which are correlate really well with NASA's Cygnus satellites, and NASA is evaluating our soil moisture data now for operational use. And we only have 4 satellites right now that are measuring soil moisture. We have upwards of 40 satellites that are doing the sea ice measurements, radio occultation measurements, and ionospheric measurements. But these reflectometry measurements require a different capability on orbit, and we've got 4 satellites right now that are doing this, and we will continue to grow that constellation as well. In terms of ocean surface, like I said, we're getting ocean surface wind speeds, ocean surface height, and ocean surface roughness. This just is a sample of the kind of data we're collecting. Very comparable to, NASA has already evaluated this data, and it's very comparable to existing satellite data for ocean surface height, roughness, and wind speed. Like I said earlier, we're getting into space services where we offer hosted payload and custom CubeSat capabilities. You can see our current constellation is all 3U CubeSats. We'll launch our first 6U CubeSats in the first quarter of next year. And we're offering both 3U and 6U currently, and we're working on the design for a 12U bus here in the future. Some of the unique advantages from Spire are that we're very quick. Like I said, we've demonstrated the ability to go from concept to on-orbit operations in less than 6 months. We're very scalable. We already have 120 satellites in our constellation. We're working up towards 175, which is what we're licensed for right now. We will probably extend beyond that. And then we are fully secure from data collection on orbit through data delivery to the customer. So just quickly on employment opportunities, Spire became a publicly traded company back in mid-August, and we are growing really rapidly right now. If you just look at our current job openings, we've got over 60 openings on the website. More than half of those are in engineering disciplines, and you can see the range of engineering disciplines there. Everything that you would imagine a space company needs, because we are a vertically integrated space company. We do everything except for the launch in-house. So we design and build our own payloads. We assemble and test our spacecraft. And so you can see the need for engineers across the board there, as well as the other areas are increasing somewhat because of the becoming a publicly traded company. The oversight is just a lot different than what it is as a private company. So lots of finance, legal, business operations folks. So there are lots of career opportunities here. And what I hear from my counterparts at the other companies like ours is that they're in the same mode right now, just rapid growth. We can't find enough qualified people. So if you're interested in an opportunity in the new space industry, you'll definitely find it. There are lots of opportunities out there right now, both science and engineering. And I lump the science job opportunities under engineering as well. But there are science opportunities here that go along with our big data analytics, applications of our remote sensing to problems on Earth. So yeah, just lots of opportunities and lots of needs that we're trying to fill right now. And then just a little bit about me. So I got both my bachelor's and master's degrees in engineering mechanics from Georgia Tech way back in ancient history. I can tell you that has provided a really, really strong foundation for lots of different things I've done over the course of my career. I've been working in aerospace and defense, both in government and industry, for over 40 years. And started out in engineering, moved into research and development, and from there into program management. That was really the first maybe 10 years or so of my career right out of college. I moved to Washington, D.C. to go to work at NASA headquarters and was a program manager there. Research and development program manager at NASA for 10 years. I was fortunate in getting an opportunity to go to work in the White House Office of Science and Technology Policy, where I did space and aviation policy for 5 years. And then I've been in business development, sales, government affairs ever since. So you know what your chosen career path may be different than what turns out in reality. But I can tell you an engineering or a science foundation is going to serve you well throughout your career. And I am still learning. I'm in graduate school right now studying small spacecraft engineering. So I don't need it for my job, but I'm interested in it. So I decided to go back to school and had to relearn all my calculus and learn all the new tools that everybody's using, like MATLAB and Simulink, all that good stuff. So it keeps my brain active, and I'm really enjoying what I'm doing. So with that, I mean, that's kind of the overview. I'm happy to answer any questions about our capabilities, about our products, about your career path, what you're studying, what you want to do. So I'll open it up.
So thank you for this very interesting talk. So yeah, we have like some question from the chat, and we can probably start with a very broad question. And it is, what do you think the future of aerospace will be?
Wow. That's a really broad question. The future, so let me separate it out. The future of aviation and the future of space. So in aviation, we're moving to a fully automated, maybe not autonomous, but it'll still have human in the loop global air traffic management system. GPS made a huge difference in the way aircraft operate. So, that is going to continue to be a challenge. Implementing a global GPS or GNSS driven air traffic management system that is seamless across national boundaries. That's a huge deal. Clearly, we've got to address the climate impacts of aviation. So there's lots of opportunities there in terms of fuel efficiency and emissions reduction. When I started at NASA, I was working in the aviation industry for before that, and then at NASA, I was working in the aeronautics program, and we were looking back then at high-speed research. It didn't work out at that time, back in the early 90s, but we will get back to supersonic travel over land again. And that's not in the too far distant future. And then from a military perspective, we're moving into hypersonics, and it's all science and engineering problems. So great opportunities there. On the space side, growth in space is just unreal right now. You watch what Elon Musk is doing with Starlink and his launchers. You look at what OneWeb is doing. The opportunities are just boundless right now. I mean, the market is wide open for companies like us. Even, I mean, we're a small company compared to somebody like SpaceX, but we're making inroads, and we're filling in gaps that the big companies don't fill right now. So there's tremendous opportunity in both traditional space, large satellites, large launch vehicles, because those are always going to be needed. But there's this new opening for smaller satellites that are enabled by low-cost launch. And I don't see that trend abating anytime soon. The costs keep coming down, the quantities keep going up, and there are just things you can do with large constellations of spacecraft that you can't do with single spacecraft. So that's, in my view, that's what you're going to see continuing in the future. We have to address the orbital debris problem, and we will do that, as an industry government collective, as an international collective. We've got to address this issue of space traffic management. So that's another area that is wide open for research and applications right now. Space traffic management, I think, is probably I don't want to say undiscovered area, because people have been talking about it for a long time, but it's finally starting to get people's attention. The fact that we've just got to do something about this. And, maybe it's going to take a major incident to spring loose some money to go address this, but it will be addressed eventually.
There's another question. So they were asking, in what ways do you use machine learning in your company?
Yeah, that's a good question. So our numerical weather prediction capability uses machine learning and artificial intelligence in its data assimilation process. We use machine learning in our constellation management. It's impossible to have a human in the loop when you've got 120 satellites and 32 ground stations, and you're doing upwards of 50,000 ground contacts a month. So we use machine learning pretty extensively in our constellation management our satellite operations. I don't know that we're using machine learning in our Earth observations right now, but I mean, we had an AI/ML team that was supporting our numerical weather prediction capability. They've now been kind of pulled out and are a corporate asset because we're finding that machine learning, artificial intelligence, and machine learning apply more broadly across the company. We're using it in finance. Our machine learning team out in Boulder, Colorado, is a strong corporate asset right now.
So we have another question from one of the viewers, and he was wondering, how do you use your technology for geological research, such as tracking ground movements?
So, GNSS plays a big role in that area. We are not looking specifically right now at geological activities. We are able to do some really interesting things with like volcanic activity and tsunami detection, because both of those have are reflected in the ionosphere. If you monitor the ionosphere, you can actually pick up disturbances in the ionosphere that are caused by things happening on the ground. Nuclear detonation detection you can do from ionospheric measurements. You can actually detect hypersonic vehicles, looking at their impact on the ionosphere. You can detect volcanic activity and earthquake activity and related tsunami type activity. So we're not doing direct measurements of geological activity, but we are able to use some of our other Earth observations for measuring those kinds of events.
Okay, there was another question, and it was asking if, with all the data that you've been collecting, have you ever been, and the data being encrypted, have you ever been confronted with any hacking attempts?
I want to say no, but I have to think the answer is probably. We wouldn't advertise it if we were, but to my knowledge, we've never had an incident where data was tampered with or our satellites were tampered with. We pay pretty close attention to cybersecurity. That's why everything that we collect is encrypted all the way through delivery to the customer. But no, not that I'm aware of. But like I said, with as much data as we've got, with as many satellites as we've got, as many ground stations as we've got, somebody has probably tried to get in. But to my knowledge, there hasn't been success to date in hacking our system. The government is starting to pay closer and closer attention to cybersecurity, even for small space systems like Spires, and we know that that's going to be a big impact on us in the future. Sorry about that. Hold on a second.
No worries.
Okay. Sorry about that interruption.
Yeah, no, that's fine. Sorry. We have now a question from Origins, and he was wondering whether you could work for any country in the world, or if there's like some limitation.
So I'm not sure I understand the question really. Can you repeat it?
Like, can you like sell your like data to any country or?
Oh yes, we are.
Like
We're definitely. Yeah, we're definitely a global company. We have customers all over the world, both commercial and government. We have, although we're a U.S.-based company, we have offices in Luxembourg, Singapore, Glasgow. We'll probably be opening new offices in the future. All of our satellites are built in Glasgow. The Luxembourg Space Agency is a big customer. ESA is a big customer. EUMETSAT. So we have customers definitely internationally. I would say maybe upwards of half of our business is international right now.
Yeah, that's very interesting. Another question that was posted is, after such a successful career that you've had, why did you choose to work for Spire?
Oh, that wasn't even a question in my mind. I was working for a large aerospace company when Spire reached out and asked me if I'd be interested, and I jumped at the opportunity to join the new space community. It's just so exciting. And, I've been with the company almost 2 years now, and there hasn't been a single day when I haven't looked forward to going into work. So it was a good decision. This industry is fabulous. It's just full of really bright people, energetic people, innovative people who, have they're interested in making the world a better place, and that matters to me too. In fact, let me go right back up to the top. Let me stop sharing here a second. I think my first slide, which I skipped. Come on, I'm almost there. There. You can just read it in our vision statement. Spire wants the information we collect and analyze to help make our world a safer, cleaner, more prosperous, and more equitable place. And I'll bet you'll find a similar statement in most of the new space companies' vision, mission, goal statements.
Thanks, that's really interesting. We have someone wondering about your opinion about like the future when you were young. Like, what you thought it would look like?
What I thought, I'm sorry.
Like, he was wondering because like in the past we used to use like very heavy computers, very big, and was just wondering what you thought the future would look like.
I was there for the transition from mainframes to PCs and worked through that. I was working at Lockheed when we got our first desktop computers. When I was in graduate school at Georgia Tech, I was doing programming on a Cyber 360 with punch cards, and I had no idea we'd be where we are today. I mean, it's an amazing time to have lived through, and yet when you look at what's happening right now, the future is going to have as much change in the next 20 years as I've experienced in 40 years. Probably as much change in the next 10 years as I've experienced in 40 years. I mean, that's how rapidly technologies and capabilities are developing. And it's a lot of it is the cross-disciplinary stuff too. I mean, we're getting into biomimetic systems. I mean, where we're taking things from biology and applying them to it's just it's amazing. And what's happening in the quantum world with quantum cryptography, quantum communications, quantum computing, and we'll end up with quantum sensors as well. So this whole thing is going to change again.
There was another question as well in the chat. So by Sebastian Rimmer, he was asking about early career opportunities that Spire offers and how for people who are looking to get into the aerospace industry. Yeah.
So by early career, I don't know if you mean like internships or things like that, but we have done internships. We don't have a formal program of interns right now. It's something we're looking at, but I can tell you that when you come into Spire, it's like gaining another family, and it's another global family because we are constantly communicating around the world with our colleagues, trying to develop new ideas, new applications for our technologies, and it's just amazing the diversity of viewpoints and that you get when you're doing brainstorming activities. You come up with applications that I never would have thought of based on my background, but somebody from Africa or the Middle East, may be able to identify a need that we just didn't even understand before, didn't even know was there before. So, yeah, it's really like joining another family. You make a lot of friends very quickly here because the pace of progress is so quick. You have to solve problems collaboratively. So, yeah, the support for new engineers coming in to the company is very strong. We have a strong training program, a strong support program in terms of improving communications, and we have education support as well. In fact, I'm taking advantage of that right now. Spire is paying for my graduate school work. So yeah, that's it's a great place for a new engineer to work because they're going to be immediately put on solving problems that need to be solved.
Thanks. That's very interesting. We have a question from someone, and he was asking whether you also provide your data to companies such as SpaceX, especially as now with over different tourist launches that are probably going to come in the future.
So I mentioned that we have a spaceport weather forecast package that we're offering. We have spoken with SpaceX about supporting their launch needs with our numerical weather prediction capability. Don't know where that's going to go, but we have had discussions with them. But yeah, a large percentage of our business is commercial. So we have customers like the large maritime companies like Maersk, Oldendorf. They're big customers of ours. Increasingly, we're finding that the finance and insurance industry needs data like we provide to help them with their analytics. The commercial sector is a large part of our business right now. We're much more than just government sales. And actually, the innovation process, I would say, is increasingly driven by the commercial sector. because when they have a problem that has to be solved, they'll spend the money to do it. It doesn't take 10 years to develop a government-funded program and you know, all that bureaucracy and administrative stuff that goes along with government programs. They can be lucrative, but slow.
So I think to add to the last question that was asked, they're wondering. So one of the viewers is wondering how could he best prepare himself for this industry? Like what should he do other than obviously having, you know, a degree in the field? What extra you know, courses or things should he do before entering?
So one thing I would do is go look at the job descriptions and figure out what it is you really have an interest in. And then the job descriptions usually have some description of what background is needed. I really believe the job descriptions are a good way to prepare yourself, because if you're taking courses that meet those needs, you're going to find a market for your capabilities. And also, you know, reading through job descriptions, you can kind of figure out what it is you like, what you might not like. But most of the engineering jobs are pretty exciting jobs in a company like this, because you're impacting the growth of the company, the success of the company. So, yeah, I would pay attention to the job postings and make sure that the coursework addresses those needs. And then, you know, participation in things like this that you can put on your resume, external activities, you know, unrelated to school, especially if it's in a technical area. All those are helpful when it comes to interviews and evaluation of candidates.
Someone was asking whether you already worked with geologists and if there's a difference between engineers and geologists.
Between engineers and what?
Geologists.
Geologists?
Yeah.
So, yeah, there's a big difference between engineers and geologists, although there is engineering in geology also. Trying to think if we make use of geologists in maybe our surface soil moisture work involves some geology. I think that's probably the extent of where we would get into geology. There are other space companies, though, that are looking at going to the moon and doing mining on the moon. So, you know, that's going to be heavily driven by geology. They're making mineral maps of the moon now in anticipation of being able to mine minerals up there. So it's not something that our company is doing, but that is being done by small space companies right now.
So I guess I'll ask you a question that I have.
Sure.
So having been in industry for like 40 years, would you say if you were to go back in time, what would you do differently? And were there things that you would have done? Yeah, basically, what would you have done differently, or would you have done everything that you've done?
That's an interesting question. I did take some chances over the course of my career in terms of, reaching out and trying to do things beyond what my existing job, and that's always paid off. Trying to extend, I probably would have done more of that rather than, sitting in the same job for 10 years until I got tired of it and then looking for something else. I think I would recommend to anybody who's in this field that you stretch yourself beyond what you think you can do. And so, yeah, taking chances in your career is, I think anyway, has a high payoff. When I was at NASA headquarters, I wanted to find out what it was like working at high levels in the policy arena, and I found a government program that sponsored people to go do that, and I found my way to the White House, and my whole objective there was it was like a 6-month program. My whole objective was to show them that they needed me full time there, not just for 6 months. And I ended up being there for 5 years. So, and that provided a foundation for going into business development. Some of those decisions you make, and especially the ones that stretch your capabilities, are the ones that pay off the most.
Someone was wondering group chat in the chats on YouTube chats whether you see any pathways for commercialization of robotics and advanced manufacturing space.
So yes, those. I don't think for our company, we're not going to be doing in-space manufacturing. Our satellites are essentially robots, but yeah, there's going to be more and more of that. Lots of early stage work in space manufacturing right now. Not sure where that's headed. Not sure what the applications are going to be, but when it comes to in situ resource utilization on the moon or Mars, building livable environments on the moon and Mars, it's going to require robotic and manufacturing capabilities for manufacturing things that we don't know how to manufacture right now, using resources that we don't know how to use right now. So yeah, that's a wide open field. I would say it's a little further off in the distance before we actually see applications.
So I guess the final question will be a summary of all the questions that have been asked, because I found that a lot of the questions were basically asking for tips and advice for entering the industry. So I guess that would be a good way to end it.
So number one, as much education as you can get. If you're thinking about going the PhD route, realize that that's going to maybe even limit your prospects to research and that kind of area. I would say minimum bachelor's, preferable master's, PhD if you know exactly what you want to do and where you want to do it. But a master's degree definitely separates you from the crowd. So that's a good thing. As much technical breadth as you can get Don't focus in on one specific area. Get as much knowledge as you can about cross-disciplinary research, development. Most of the engineering schools will have projects that are interdisciplinary. Do those as much as you can. Think if there's anything else I would suggest. Extracurricular activities that are not totally unrelated to what you want to do. Those are always helpful. Participating in and actively participating in societies, that's a good thing. Because you make contacts, you develop networks, and I think that's the one I would end up with is networking. It is really important because you never know when that person you developed a relationship with that you had no idea where it was going, it is going to pay off at some point in the future. So networking is extremely important. As early as you can, as wide as you can.
Thank you very much for this talk. It was really amazing to hear about what you have to say about space and space careers. So yeah, thank you for your time.
Sure.
Yeah, thank you so much. It was very interesting.